Hello everyone, welcome to Computer Science 226, lecture number 20. Okay, today is October 22nd. Today we're going to have a short video with some practice exercises at the end, which I prepared for you. First off, I want to make an announcement. Midterm number 2 is coming up. It's going to be on Thursday in a week, October 28th. Okay. So you know the routine. Everything is closed, 75-minute long, not comprehensive. Okay, so you need to learn only everything from the first midterm up until today and what we cover on Tuesday next week. Okay, it's going to be online on Blackboard. Okay, let me know if you have any questions. If you have some material which doesn't make sense, let's discuss that on Tuesday. Okay, prepare the questions. Polymorphism. Okay, so just let's repeat that. We were talking about subtype polymorphism, right? So the idea is that if you have a circle, which is a subtype of a geometric object, and geometric object is a supertype of a circle, okay, the inheritance relationship enables the subclass to inherit features from its superclass. Okay, a subclass is a specialization of a superclass. Okay, so circle is a specialization of a geometric object. Okay, so it's the same thing as geometric object, but with some special details, and that's why every instance of a subclass is also an instance of a superclass, but not vice versa. Okay, so circle is also kind of a specific example of a geometric object, but not vice versa. For example, every circle is a geometric object, but not every geometric object is a circle, right? Because just, I guess in general in geometry, a rectangle would be a geometric object, right? But it's not a circle. So it only works one way. Therefore, you can always pass an instance of a subclass to a parameter of its superclass type. For example, this code, right? So what do we have here? We have main method, right? And we have another method, display object. So what do? We accept an object of the type a simple geometric object, okay? And in both cases, like both of those calls will be valid. In the first one, since simple, hold on, circle from simple geometric object. Yeah, okay, yeah, so we expect a simple geometric object. In the first one, we're going to create a circle from simple geometric object. We need to assume that circle from simple geometric object and rectangle from simple geometric object as classes, they're created somewhere, it's just not displayed here. But anyway, so we're going to create a circle from simple geometric object, and we're going to pass it over here, and that's going to be accepted with no problem. Okay, why? Because circle from a simple geometric object extends simple geometric object, right? As we can guess by its names, by their names. Yeah, so that should not create any issues. Same thing with the rectangle from simple geometric object. Okay, any instance of rectangle is also an instance of a simple geometric object. Okay, so both of them are going to work. So you see here, the parameter name is object. So later we can say object get date created, and get date created as a method should be available in both of the classes, both circle from a geometric object, from rectangle, from simple geometric object, and also it should be available in the simple geometric object as well. Okay, so it should be available in all of them, in all three. Get color, same thing. It should be available in all three. Okay, so supposedly it's red and black. That article which I showed you. Okay, so let's talk about it one more time. So polymorphism is the ability of an object to take on many forms, right? So poly is many, morph is a shape form. Okay. The most common use of a polymorphism in OOP occurs when a parent class reference is used to refer to a child class. Okay, parent reference is used to refer to a child class object. Okay, here's an example. Public interface. Don't think about what. Just scratch the interface and say I don't know, class, something like this. Don't think about what it means yet. Anyway, so we have vegetarian, we have an animal, we have a deer which extends animal, and implements is just a special word for interfaces, right? So, but anyway, so imagine that deer extends animal, and deer also extends vegetarian. Okay, so imagine for a second it was possible in Java. In this case, it just creates is-a relationship, right? So deer, what is it? If I'm creating an instance of a deer, that's also an example of animal, That's also an example of a vegetarian, right? Because it extends from both of these classes. Deer is also an example of a deer, right? Because so any object is an instance of its own class, of course. And the deer is also an example of an object, because object is a parent of all the classes. Okay, so all classes implicitly extend object. Okay, so although you're not typing like, I don't know, deer extends object, but that's already there. That's kind of burnt in. That's built in Java. Okay, so deer D is equal to new deer. Okay, now I can say animal A is equal to D. You see, so basically I'm assigning deer to animal, and that will be valid. Why? Because deer is a specific instance, more specialized instance of a class animal. Same thing with vegetarian, same thing with object. But again, keep in mind that you cannot go the other way. So you will not be able to say, okay, you will not be able to say, for example, animal A is equal to new animal, okay, and then say deer D is equal to A. So this will not be allowed, right? So again, it only works one way. Yeah, that's not important. Okay, hope it makes sense. Again, it's not like there is nothing difficult, and it is not like you need to have a lot of practice in order to understand it. It just all conceptually should make sense. Equals to, okay, so that's the new material equals to method. So remember we were talking about toString method, right? And kind of similar to toString, right? Equals method should also be declared everywhere in any class you're creating. Okay, so that's kind of considered to be professional when you create a new class and you just also create an equals method. Okay, and you kind of like similar to toString. Okay, so equals and you pass in an object. So what does it do? I remember that for strings, right, we were not able to compare strings like, we can, for example, say, I don't know, string A is equal to like A like this, right? And then, okay, now if I want to compare them, okay, I cannot say that. Why? Because again, it just those are the objects, right? I cannot compare objects like this. In this case, the addresses will be compared, so that's not allowed. In this case, what should I do? Whenever I want to compare two objects of complex data types, so nothing primitive, right? So anything apart from the primitive. Okay. In other words, anything which kind of the data type of which starts with a capital letter. I cannot use double equal sign anymore. I need to say equals. Okay. Equals B. Okay. And I'm passing B as a parameter. If that is true, then system.out.println same, right? So now, if I run it, same. Okay, perfect. Why? Because the content is the same. The content of these two objects is the same. Now, if I say, by the way, what happens if I say A? Should it be the same? Yeah. If I say B here, then nothing will be printed out, right? Because the content is now different. Okay, hope it makes sense. So, in order to compare two objects, what do you need to do? Do not use double equal sign, use equals method. Okay, now the question is, what if, for example, I'm creating a class, a new class, student, okay, and that class has, so I'm creating a completely new class, right? So for example, it has int id, which is equal to 0, string major, which is by default equals to not available, string, what else? Year. Okay. So not available also either. Okay. Yeah. And again, so it'll be very nice to create a public method which will be called toString, right? and that's something we talked about before. But for equals, is the same thing, right? So again, for every classes, it's very professional to create a method which is called equals. So what does it do? It returns either true or false, depending on if two objects are the same. Okay, so if it returns true or false, we need to say boolean here, then equals, okay, and then here you need to specify what you want to allow compare the student to. For example, if I want to allow to compare student only to students and everything above, no, everything below the student, right? Yeah, everything below the students. Okay, so everything which can extend students. In this case, I can say student. Student, I don't know, E. Okay, and then here I'll be comparing them. If I want to allow anything, then I can say object E. Okay. Most likely, though, I will be comparing them to students and children of students, child classes, right? Subclasses, subtypes of students. Okay. And now the question is how can I compare students in this particular case when I only have like 3 parameters, for example. So since you're designing the class, it's completely up to you. So you just, as a designer of the class, you need to make a decision. What does it mean to have 2 identical students? Okay, so when they're the same, what does it mean? If, for example, I have an ID, right? So if IDs are the same, is that enough or not? Or like ID and major needs to be the same, or just maybe, I don't know, major and the year would be the same, right? Probably, most likely, I guess, most often, right? So almost all the time, in other words. All the data fields need to be the same in order to make sure that the students are the same. Okay, so usually what happens is this: unless, as long as all of the data fields are exactly the same, then you return true. Otherwise, you return false. So as long as you have at least one contradiction, for example, ID is the same, major is the same, but here is different, then you return false. Okay, so it just takes only one of them to be different, and usually it goes like some kind of Boolean statement. For example, to say if this dot ID is the same as e dot ID, right? And this dot major equals e dot major. Okay, and well, since it says there, like, well, I probably want to make them public. I don't know. For this particular example, of course, you need to use encapsulation. You need to hide everything. Okay, and this dot here is the same as e dot here. Okay, so if that's true, and that's true, and that's true. Okay, so and, right? In this case, I return false. Oh, sorry, I return true, right? That means they're the same. And then return false. Okay, so usually that's what it looks like, usually. And also, sometimes there is some kind of sanity check before. Sometimes, yeah, there'll be some kind of sanity check. It's just making sure that you pass in the student, and student is a valid student, something like this. But we assume that it never happens for now. Okay, cool. Does that make sense? Hope it does. Again, equals. Please create that method for all of the classes you created. Okay. Another method defined in the object class that is often used in equals method. The signature is public boolean equals object O. Okay. This method tests whether 2 objects are equal. Again, what does it mean to be equal? It's completely up to you. The syntax for invoking is object 1 equals object 2. So these 2 guys are compared, object 1 and object 2. The default implementation of the equals method object class is this. So this equals object, right? So basically they're comparing addresses, right? So that's something you should definitely not do. Oh, equals to. Yeah, by the way, hold on. That's just equals, not equals to. That's a tiny mistake. Hold on. Okay. The implementation checks whether to reference variables point to the same object using the this operator, right? So again, it's not true equality, right? You should override it. You should override it in your custom class to test whether two distinct objects, right? So distinct objects have the same content. Okay. So usually when we say that students are the same, that means those objects have exactly the same content. Public boolean equals object O if O instance of circle. By the way, that's a very, very interesting operator. Basically, what it does, it returns true if this, okay, whatever this is, well, as you can guess, an instance of this class, right? So here you put an object, here you have a class, right? So if this guy is an instance of this class, and including all the subtypes, right? So if this is an instance of a subtype of a circle, then it's also going to return true. Okay. Yeah, if I'm not mistaken, hold on. So instance of Java returning true for subtypes. I really hope I'm not mistaken. A is a parent. No, it should return false. Yes, it would. Why should not? Child with child. Parent, child A extends parent. Okay. Parent. Okay. And where is instance of? I have not compiled it. Okay. I have a class child that extends parent. Child, instance of parent. Child extends parent. So if child extends parent, yeah, right, yeah. So child extends, yeah, right, yeah. So that should return true. Perfect. Okay, yeah, that's what I'm thinking. Okay, yeah, instance of will return true if it's a subclass. Yeah, awesome. So that's what I meant. Anyway, so if O is an instance of a circle, or if O is an instance of a class which is a subclass of a circle, then instance of is going to return true. Okay, but it does not mean that those guys are the same. Like this O object, right, and the object we're inside of, it just returns true if the types are the same. So if those guys are the same, that means this returns true, and then we just need to make sure that the radius is the same. So we compare radius to circle, so O.radius, right? And keep in mind that we converted O into a circle, right, using this typecasting. Okay, otherwise return this .o, which means returning the address. It returns true if the address is the same. Okay. Hope it makes sense. The most important thing again here is that what equals to is, how it works, when does it return true, when does it return false, right? And the idea is that you always need to implement it for all the classes you're creating. ArrayList, okay, ArrayList. So what is ArrayList? One of the fundamental issues with arrays is this. If I create an array, int array is equal to new int, right, of 10, right? In this case, what happens is that, let's say 5, somewhere in the memory, okay, 5 integers are going to be created, 5 placeholders, right? So that's 1, 2, 3, and 4, 5. Okay, so I have 5 placeholders, 5 integers. Each integer is 4 bytes, so basically I'm going to create 20 bytes, right? And the idea is that, unfortunately, if I want to add one more cell, so one more integer to that, and make it an array of 6, right? That's not possible, unfortunately. That's how it works in Java. In Python and in JavaScript, but JavaScript has a different way, and I think Python also makes it lists. But anyway, so in the super old languages like Java and C and C++, that's impossible, right? So basically, yeah, so it's impossible to do anything like that. Also, the same thing, like if I want to delete this one, and if I want to delete these two, and just have like only 3 variables, in this case I cannot do that either, right? Because again, it just already set aside this many variables, that much space. Okay, so for primitive data types, that's impossible to do. Yeah, and if I have, like, for example, this array, and if I have another array, I can't really kind of add all the elements of this one and that one all together. That's also not allowed. Okay, so that's kind of, sometimes it's very inconvenient to manipulate the arrays. That's why they created a class which is called ArrayList. Okay, so that's a class which is built in Java. It's not a primitive data type anymore, so you need to create, you need to use a new operator, new ArrayList. Yeah, once array is created, the size is fixed. You cannot add or remove elements from such array. So here's the UML diagram, right? So what can we do? We can add. Well, first off, one thing which is very important: array list is still an array of a certain type. Okay, so you cannot mix types. Like within one variable, within one array, you cannot put like a student, a circle, and an integer. You cannot do that. At least you can't do it yet. We'll talk about how to do it later, but you can't do it so far. Okay, so you still tie that. You're still basically saying that I'm going to create an array list of some kind of data type. That's important. Okay. Yeah. So what kind of methods do I have? I have add, right? So I'm going to add an object e, right? So again, it's object. So due to the polymorphism, basically means everything. I mean any class, right? Add index int e. So that means I'm going to add an element e at a certain index. Okay. Clear. That means it's going to remove all the elements from the array list. Contains, that returns true or false. Okay, if the object is contained there. By the way, very good question. How does it work? So how can I make sure? So imagine if I have an array of students, right? So so imagine if I have an array of students, and I want to ask if one of the students is contained inside of that array. Is that going to compare the addresses, or it's going to compare the content, right? So using equals. Think about that. Get. Okay, so that basically returns the element which is located at the index, right? Index of. So get is basically very similar to if with arrays we had, we used to say, for example, array of. Can't do that. Okay. So anyway, if we used to say like array of 2, right? So now when we say get and we say in 2, right, in the parentheses, it basically returns us the second element in the array. Index of, okay, object. So basically providing the object, and that's going to return an index of that object in that array list. Okay. With the first matching element. And of course, as usual, if that element is not contained inside of the array, it's going to return -1. Is empty, right? So it returns true or false. If it's empty, it's true. If it's not empty, it's false. Last index of, again, same thing as a string, right? So if it's going to find the index of, but it's going to search from the right-hand side. So imagine kind of like that's my array list, right? It has, let's say, 4 elements. Okay, and these two guys are the same. Okay, so in this case, if I run index of, right, it's going to return me 1. Okay, if I run last index of, it's going to return me 0, 1, 2, 3, right? So it's going to return me 3. Okay, because 3 is the last index of the element I'm looking for. remove, okay, and that's kind of the key point, that you can remove elements from the array list. You just say remove, you pass in an object, and that's going to be removed. It's going to be found and it's going to be removed. And what's interesting is that, think about this, I'm going to be removing an object and it returns Boolean, so it returns either true or false. So I remember when I was learning that, the question I had is, when would it return true, when would it return false, like if I'm asking to remove it. Okay, so the answer is it returns true if an element is removed. Okay, so if it was able to successfully remove the element from the list. For example, if I want to remove like this element, right? In this case, at the end, I need to have array list with 3 elements. Okay, and so this one is the same, this one is removed, this one is here, and this one is here. Okay, so if it is possible to remove one, okay, then it returns true. So now, if it was able to remove it, okay, because there are some circumstances where it can't do that. If it can remove it, it's going to return true. If it was not possible to remove it, for example, if that element was not found in the entire list, right? So you cannot remove an element which is not contained in the list. In this case, it's going to return false. Okay, size, what does it do? It returns, of course, like the number of elements there, right? Because it's dynamic, so it's not like, for example, fixed as it was with arrays. Yeah, and removed index, right? So it's going to do the same thing as this, but it's going to remove an element at a certain position. Okay, same thing, returns true or false. Set, okay, so basically it's going to replace an element located in an index with an element we specify after the comma. And that's going to return us, I think it's returning, so after it replaced it, right? For example, if I want to replace, so imagine if I want to replace this guy with this one, okay? In this case, I think it's going to try to replace it, and it's going to return whatever is located at that index, right? So in this case, it's second. So basically, if it was successfully able to replace it, it's going to return exactly the same thing which we passed. If it was not able to replace it, it's going to return whatever is currently located at that position. Okay, cool. Moving on. Here's the syntax. Okay, so you say array list, and then you have like angular brackets. It's a new thing. Don't really think about what it means yet. We'll be talking about that later. But basically, the idea is that we create an array list of strings, right? So we basically tying that data type to array list called cities, and then we say new array list, and then we need to put here exactly the same data type as here, right? And then since it is a constructor, 2 parentheses in order to call a method. Okay. Yeah, hope it makes sense. Hope it makes sense, and you'll be practicing with it here. Moving on. So how to prevent overloading and overriding. Okay. You may occasionally want to prevent classes from being extended. Okay. In such cases, use the final modifier to indicate that the class is final and cannot be a parent class. Okay. Sometimes it's useful. Sometimes. For example, you create in a class again, and like you want to make sure that no one in the future, like a year ago or 2 years ago, will not be able to extend it. And in this case, you just say final here, and nobody will be able to say like public class something extends A. Okay, this will not be allowed. Yeah, the match class is the final. The string is the final, right? Because you cannot like extend string. String builder is the final. String buffer is the final. Is the final class. Yeah. You also can define a method to be final. Okay, method to be final. In this case, you can extend the class, but you cannot override or overload the method. A final method cannot be overridden by its subclasses. Okay, so what does it mean? Let's say you have a class and another class, right? And this class is bigger. Okay, this guy extends from here. Let's say it's A, let's say it's B, okay, And if in the class A you creating something which is final, so for example you creating the final void M, in this case B will not be allowed to have exactly the same final void M with exactly the same signature. So you are protecting that from being overridden. Okay. For example, the following method M is final and cannot be overridden. Right. So here we don't really talk about overloading. So I need to remove this. Okay. I guess from inheritance and overriding. Cool, hope it makes sense. So I hope you were taking notes. What I want you to do, I want you to complete these 3 exercises. So this one will be about ArrayList. This one is also about ArrayList. And this one is about just inheritance in general. I want you to complete all 3 of them, and I want you to run them on your computer, take a screenshot, and please submit it today along with the notes. Okay. So submit this code, or the screenshots, right? Shots of these exercises alongside with your notes. Okay, so please take screenshots with the phone or just using the snipping tool and submit them today. I hope you guys enjoy that. I'll see you on Tuesday. Please expect the homework to be on Monday. Bye bye.